So here we go, we have another word problem here, a word problem for us to play with. And it goes as follows. Let's read it together. Jane is 3 years older than her brother John. Jane is twice as old as her sister Kat. If the sum of the siblings' ages is 17, what are the siblings' ages? So here what we're going to do is we're going to try and figure out how we can find out what the ages of the siblings are. So let's pretend that we have John has let's say John is J. This is John's age. Okay. So let's say J is John's age. Then I know that John is J. Jane is 3 years older than John. So it would be, Jane would be J plus 3. So this is Jane's age. And finally we know that Jane is twice as old as her sister Kat. Jane is twice as old as her sister Kat. So Kat would have to be J plus 3 divided by 2. This is Kat's age. Okay. So this is the first step in solving this word problem. Going from a verbal description of the problem into an algebraic formulation of the individual pieces. Let's read this one more time. Jane is 3 years older than her brother John. Jane is twice as old as her sister Kat. If the sum of the siblings' ages is 17, what are the siblings' ages? So Jane is 3 years older than the brother John. So if we have John being J, then J plus 3 is Jane. And if Jane is twice as old as her sister Kat, then Jane's age, J plus 3 divided by 2, has to be Kat's age. And then it says, if the sum of the siblings' ages is 17, what are the siblings' ages? So now we can add these together. We know that John's age plus Jane's age plus Kat's age has to equal 17. Because that's what they tell us. If the sum of the siblings' ages is 17, what are the siblings' ages? So now we've created an equation that captures the situation of the problem. And now we just have to figure out how to solve this. Okay? So we have this 2 on the bottom of this fraction. So if we multiply the whole thing on both sides by 2, we can get rid of that 2 on the bottom there, and everything will look a lot easier. So I'm going to multiply everything on both sides by 2 here. So it'll be 2j plus 2j plus 6 plus j plus 3 equals 34. Because 17 times 2 is 34. This is j plus 3 because j plus 3 divided by 2 and then multiplied by 2 is this j plus 3. Then I add like terms here on the left hand side. 2j plus 2j is 4j, plus j is 5j, and then plus 6 plus 3, that's plus 9, equals 34. Here I'm going to subtract 9, and I get that 5j is equal to 25. Perfect. And then we divide both sides by 5. And we see that j is equal to 5. Because 25 divided by 5 is 5. So now we can populate these values. J has to be 5, which is John's age. Jane's age is 8. And Kat's age is 4. And there we go. Jane is 3 years older than John, and Jane is twice as old as her sister Kat. Ta-da! While I'm at this problem, I want to show you that we could have tried to do it in a different way if we had picked a different sibling to start as our variable. So let me do that now real briefly so that we can see it done a different way. Let's pretend that instead of having picked John, which was a very reasonable choice, of course, I had picked instead Kat's age, K. Then Jane would have been twice as old as Kat, so it would have been 2 times K. And then it would have said that Jane is 3 years older than her brother John. And so John would be 3 years younger than Jane. So it would be 2K minus 3. Okay? So now let's recap how I got this. If I let K be Kat's age, then Jane is twice as old as her sister Kat. So Jane would be 2K. And Jane is 3 years older than her brother John. So John would have to be 3 years younger. So Jane's age 2K minus 3. So now we see that sometimes the verbal description of a problem can be translated into an algebraic expression in more than one way. So it doesn't have to always be one way. As long as we're reading the problem correctly and we're forming a correct model over here with the algebraic expressions, we can solve the problem. And now I'm going to take it from here, just like we did a moment ago. So we're going to add up these ages. 2K minus 3, which is John's age, plus 2K, which is Jane's age, plus K, which is Kat's age, gives 17. Because it tells us that the sum of the siblings' ages is 17. We now combine like terms, and we get that 2K plus 2K is 4K, plus K is 5K, minus 3 equals 17. And then we plus 3, and we get that 5 times K equals 20. We divide by 5, we divide by 5, and we can see that K has to equal 4, which would mean that Jane would have to equal 8, which would mean that John would have to equal 5. And so again, we have received the same solution set as before. And if you'd like, you can imagine later how you might want to do it if you were to represent Jane's age and form algebraic expressions from there. And there you go. Ta-da! Another word problem solved.